It is the golden age of Greece, a unique window of time that gives birth to Western ideals of beauty, science, art, and a radical new form of government: democracy. To immortalize those ideals, the Greeks build what will become the very symbol of Western civilization: the Parthenon.
It was the physical embodiment of their values, their beliefs, of their ideology. It remains for us a powerful statement of what human beings are capable of.
But today, solving the secrets of how the ancients designed and engineered the Parthenon has taken on a new urgency. For after 2,500 years of being ravaged by man and nature, the building is in danger of collapse. Hidden behind its columns, a rescue mission is underway. The team must take apart, repair, and reassemble tens of thousands of its pieces. And although the Parthenon appears to be geometrically straight and made from interchangeable parts, subtle curves make each piece unique, varying by fractions of a millimeter.
The quality of the engineering work and the precision is unmatched, even from us today.
The restoration team has taken over 30 years and spent well over $100 million restoring what the ancient Athenians built in just 8 or 9 years. It is clear today's technology can only take the team so far. To rescue the Parthenon, these modern architects, stonemasons, and archaeologists must unlock the engineering secrets of the ancient Greeks. Up next on Nova, Secrets of the Parthenon. Peering over the rooftops of modern Athens, from its throne atop the ancient Acropolis, the sacred city in the sky, the Parthenon rules in shimmering splendor. Even in its present form, a stark marble ruin, the Parthenon is revered as an icon of Western civilization. Its shapely, muscular columns, crowned with majestic capitals, are the very symbol of the classical world. Its height and width define perfect proportions. Its original sculptures have been looted and lusted after for their beauty. And if imitation is the sincerest form of flattery, the Parthenon reigns as the most copied building in the world. From the French Parliament to the US Supreme Court, to banks, museums, and countless buildings that aspire to convey wealth, culture, and power.
The Parthenon remains an enduring symbol. It was built to glorify Athens, but has taken on a much greater meaning. Despite the destructions of time and man, it still represents the highest level of human creativity.
But as magnificent as the Parthenon is today, it is a shadow of its former self. 2,500 years ago, the Parthenon was built as the crowning achievement of classical Greece. It towered on the Acropolis, at the center of a complex of temples and altars, vividly painted and adorned with statues of mortal and immortal greats. The most prominent sculpture stood inside, A 40-foot-high gold and ivory statue of Athena Parthenos, the patron goddess of Athens. But that was then. Where Athena once stood, today stands a crane. Not a trace of her statue remains. Now her holy precinct is a construction site. For much of her temple lies in tens of thousands of pieces, some scattered around the Acropolis, some around the world, and some lost forever. What does remain standing is in danger of collapse. Now, a rescue mission, the Acropolis Restoration Project, is trying to save it. The team, guided by the meticulous investigations of Manolis Kouris, has set the bar high, salvaging whatever ancient marble blocks remain in order to create the most faithful restoration. The cost to date is easily over $100 million.
We keep as much as possible of the original material, and we do not damage the asset material. The theory is that we preserve all the original pieces, and we add only a few marble in order to fit them to the general construction.
This capital, once atop a column, typifies the struggle they face. It is in 6 pieces, with many fragments still missing. First, master marble masons need to puzzle together what pieces they can find. Then meticulously recreate what is missing. The block itself weighs 10 tons. It will need to be hoisted to the top of a column consisting of 11 drums, of which many are also fragmented. Together, the drums and capital may have to support up to 100 tons of surviving marble beams and sculpture. But before they can hoist the capital into place, the team must solve a more perplexing problem. On which of the Parthenon's 46 columns does the capital belong? For although the Parthenon may appear to be one giant building kit with interchangeable parts, it's not. The building, celebrated as a symbol of beauty and perfect proportions, hides an ancient secret. Kathy Paraski and Lena Lambrinu, architects on the restoration team, investigate.
You think that all the blocks are square in this building, but in fact, if you check it with a set square, you can see that we don't have a right angle here.
And when Paraski places her book on one end of the stylobate, the Parthenon's foundation, it can't be seen from the other end.
This is because there is a curve in the middle of the lines and the stylobate, about 6 3/4 centimeters high.
Kouris and his team have investigated every angle on the Parthenon. And although the building looks straight, they've discovered there's barely a straight line on it. These curves are no accident. They start with the foundation, or stylobate. Each of the 46 columns has a gently curving profile and leans inward. Even the architraves, marble beams that span the columns, as well as the architectural elements above them, are curved. This means that each of the over 70,000 pieces of the Parthenon is unique and fits in only one place. And the difficulty of fitting the pieces back together is compounded by the Parthenon's history. Since it was built in the 5th century BCE, it has been shot at, exploded, set on fire, rocked by earthquakes, converted to a church, then a mosque, and in the 19th century, looted for its magnificent sculptures. To make matters worse, at the beginning of the 20th century, the Parthenon was subjected to catastrophic restorations.
More recent damage was done in the 1900s by the restoration team putting in these iron clamps. They rusted and expanded, cracking and destroying the marble.
In addition, the early restorers put column drums and whole blocks back in the wrong place. Before the restoration team could even start, they had to correct these mistakes by taking apart, block by block, much of the Parthenon. Paraski took on the Herculean task of working out the original positions of 700 scattered blocks from the long inner walls of the temple.
Although the blocks seem the same, each block is different. Each one has its own individual, unperceivable information, the cuttings, the heights, and we're talking about differences of 1/10 of a millimeter here.
That's about the thickness of a hair. The team turned to modern technology to assist them. Each stone, like everywhere on the Acropolis, was ID'd and entered into the computer system.
As soon as a fragment of marble is found, it takes a number and it is entered in the database. So far we have 5,500 architectural members of the Parthenon.
All with detailed descriptions of height, width, slope, corrosion, cracking, stain marks, even graffiti. By mapping these variables, Paraski and the team hoped to reconstruct the two inner walls.
We found about 52 criteria we could give maximum to one block of the wall. If you measure all the constructive elements, you have about 52 criteria. So we thought, let's try to put it on a computer program, to press the button and to see if we have a result.
But the puzzle proved too complex.
Mathematically it was working, but we didn't have any result.
In the end, to put her wall back together, Paraski had to draw each stone onto a card, and with the help of detailed measurements, shuffle them around.
So the final decision was made by eye.
It took 5 years to identify the position of around 500 of the pieces. It's been over 30 years since the restoration began. The Parthenon is a 20,000-ton, 70,000-piece, three-dimensional jigsaw puzzle. And worse, it's a puzzle that doesn't include instructions. No one has found anything resembling architectural plans.
Where are they written, these things? Where are they writing? Do they have so many papers, we have computers, we have everything. How they are doing and how they communicate, and we're going so quickly in 8 years. I cannot understand, I cannot imagine.
How did the ancient Athenians build the Parthenon with such precision in less than 9 years? And why with these subtle curves and few right angles? How can the modern restorers faithfully repair and reassemble these pieces before air pollution and even earthquakes inflict further damage? To save this masterpiece of Western civilization for the future, Chorus and his team of architects, engineers, and marble masons will have to unlock the secrets of the past.
The Parthenon was the greatest monument and the greatest sanctuary in the greatest city of classical Greece. It was the central repository of the Athenians' lofty conception of themselves and the physical marble embodiment of their values, their beliefs, their myths, their ideologies. It was as much a temple to Athens and the Athenians as it is to their patron goddess, Athena Parthenos.
But just 30 years before it was built, Athens lay in ruins. A victim of Emperor Xerxes, leader of Greece's traditional enemy, Persia. The Athenians rally the rest of the Greek city-states and, with a series of heroic military victories, drive out the Persian invaders. With the foreign threat neutralized and nearly 200 cities across the Aegean paying into a mutual defense fund, Athens grows wealthy. It's now 450 BCE, and a former general emerges as leader, Pericles. He spearheads an ambitious campaign to rebuild Athens and ushers in the golden age of Greece. A unique window of time that establishes Western ideals of beauty, science, art, and a radical new form of government. Demos, meaning people, and kratos, power, people power, or democracy.
This is the area of Athens just beyond the Acropolis where male citizens came to vote. We think that during the 5th century, the assembly would have comprised about 30,000, perhaps up to 40,000 male citizens.
Mid-5th century Athens was a golden age because of the constellation of powerful intellects who gathered there.
Socrates studies philosophy here. Hippocrates, considered the founder of modern medicine, according to later traditions, visited Athens. Herodotus, father of history, and Thucydides write detailed accounts of this time.
Theater especially flourished. And this was a time of Sophocles and Euripides performing their wonderful plays to the public in these theaters, including this particular one, the Theater of Dionysus, on the south slope of the Acropolis.
But while all of Athens flourishes, the Acropolis still lay in ruins from the Persian invasion. Then, in 449 BCE, Pericles proposes to rebuild the temples destroyed by the Persians. He opens the question to debate.
Every monument, every element of the Periclean building program had to be voted upon so that these monuments would in fact be monuments of the democracy and not of one man, such as Pericles himself.
In a powerful statement of their self-confidence, the people of Athens vote to rebuild the Acropolis, and at its center, a building to embody their ideals, the Parthenon. The Parthenon would be the largest building in the world constructed entirely of marble. And in tracing the path of that marble lies the first clue as to how it was built. Before the Parthenon, marble had been imported from quarries on islands in the Aegean Sea. On one of those islands, Naxos, archaeologists discover a small temple.
On the beautiful island of Naxos, we see this temple, which is one of the early archaic Greek temples made of stone.
The Temple of Demeter was constructed about 100 years before the Parthenon. It too was built with few right angles or straight lines.
We can indicate already the curvature of the base of the temple, also the widening of the lower part of the columns.
Why are these builders deliberately constructing their temples with curves and few right angles? Professor Margaret Livingstone, a Harvard neurobiologist, believes the ancient Greeks might have been aware of optical illusions.
The function of the visual system is not to transmit an image to the brain. There's nobody up there to look at an image. It's to transmit information about the world up to the brain.
Our brain translates visual information, like converging lines, to help us assess distance and relative size. But sometimes something's lost in translation. Here, the converging lines are telling us that the line on the right is taller than the line on the left. The result, an optical illusion.
This is another classical illusion. If you have two straight lines, if you add converging lines, these two lines seem to bow in the middle. So if the floor of the Parthenon has converging cues as to depth and perspective, you could have an illusory sag in the floor of the Parthenon.
Perhaps to compensate for the illusory sag, the builders left extra marble in the middle. The ancient Greeks realized that to construct a building that appears perfect, they would have to come up with a design that tricks the eye. What they invent is a system of optical refinements.
Their concern was the visual perfection of the building.
This small stone temple on Naxos provides evidence of the Greeks' keen observation over hundreds of years.
Here we can see the first optical refinements already experimented by the people building the temple. Here lies, literally, the DNA of the Parthenon.
But even with the wealth of Periclean Athens, it was too expensive to bring so much marble from the islands to the mainland. Fortunately, the Athenians discover a rich source of marble 11 miles from the Acropolis. The Pentelicon quarry became one of the largest and deepest marble quarries in the world and is the source for the restoration today. In minutes, diamond-tipped saws cut through the same stone used by the ancients. Nikos Toganidis, the architect in charge of day-to-day operations on the Parthenon restoration, is searching for a flawless 12-ton block.
Today we are going to check a marble that George found here in the quarry. It's going to be an architrave. It's the last large member that we need for the restoration of the north side.
The restoration team has waited months for just the right block to make the new architrave, the marble support beam above the columns. It costs over $1 million and will have to support up to 20 tons.
Let's measure it. Let's see if we have the length of the marble that we need.
It seems perfect, except for a hidden vein, which could compromise its structural integrity.
If there is the problem, then the sound is quite different. Για χτύπατα από πάνω, Γιώργο. Τον ήχο. Now it sounds as a bell. So we are going to buy. Γιώργο, bravo.
At the time of Pericles, teams of quarrymen extracted an estimated 100,000 tons of marble from Pentelicon. The cost of extracting and transporting it, inscribed in part on this stone placard from 434 BCE, was over 400 silver talents, the equivalent of more than 400 of their fully equipped warships.
Expenses for the construction of the Parthenon were recorded on stone annually. The stone was actually set up on the Acropolis. This is because Athens had a democratic system of government, so they required that the expenditure of public monies be made public.
The rest of the construction budget was spent on carving that marble. In that sense, the workplace today, as in ancient times, is less a construction site and more a sculptor's studio.
We have, in some cases, to form a new drum from 100 different pieces. That is a very, very difficult work.
Here, the restorers recovered a part of an original capital, but were missing the pieces to fit around it. They had to carve them by hand from the newly quarried Pentelic marble. They start by making a plaster cast of a missing piece. Then they use this ancient mason's device called a pantograph to record the three-dimensional shape of the cast and transfer it point by point to the new marble.
It's a very traditional technique. Even the Romans were using the same device to copy the sculptures in antiquity.
Once a new piece is completed, they can join it with an old. But will their new piece fit? It doesn't. It's just millimeters off. The moderns will borrow a technique used by the ancients for fitting together two new blocks. They coat the inside surface with red clay.
In the points it doesn't fit, it leaves white marks. Where the clay goes white, they have to carve it a little bit more and test it again until they have no marks when they are closing the two pieces.
The operation is repeated dozens of times until the new marble exactly matches the ancient broken surface. But even when they succeed, there's still the challenge of fitting the restored pieces precisely back into place. After months of painstaking work, drum number 14192 doesn't quite make it.
As you see here, we have a small ancient fragment. We built around it with the new addition. Now we are going to move it and take it down to the workshop.
Just a few millimeters of excess new white marble has to be cut from the base at ever so slight an angle to match the precision of the original blocks.
These differences of 1 or 2 millimeters is just a miracle. You can't believe that you have so small differences.
And here lies the Parthenon's central mystery. How did the ancients sculpt it with such precision and speed?
Ήταν βλέποντας εδώ ένα σπόνδυλο του προνάου, πάνω στον οποίο υπήρχαν αυτές οι γραμμές.
Etched into the marble itself, Manolis Koris finds a clue.
Καταλάβετε τι είναι αυτό? Το έχετε δει ποτέ σας? Όχι. Δεν έχετε δει ποτέ αυτό?
Koris made an extensive study of the relationship between tool marks and the kind of tool and force necessary to produce them. From these marks, he reconstructed a type of chisel lost since antiquity. The marks led Koris to identify a range of tools that reflect centuries of expertise in metallurgy, enabling the Greeks to produce sharper and more durable tools than we have today. And from minute differences in the chisel marks, Koris can even identify the distinctive workmanship of about 200 different stonemasons. They were recruited from throughout the Greek islands and would have had many different systems of measurement. Without a common standard, coordinating this workforce would have been a logistical nightmare. How did they do it? One answer lies on the island of Salamis, not far from Athens. Here, discovered on a church wall, was a stone carving. Today, it is in the Piraeus Museum. Architect Mark Wilson Jones believes the enigmatic Salamis stone, depicting an arm, hands, and feet, may be a conversion table for the different measuring systems, Doric, Ionic, and Common.
This is a tracing I've done that shows the stone, and you can immediately see how the main measures work. We have this foot rule here, that's 327 millimeters, more or less, the Doric foot. And here you have a foot imprint that's roughly 307 millimeter long foot, which we tend to call the common foot. And there are in fact other feet. For example, this dimension here is one ionic foot. So there's a kind of whole network of different interrelated measurements here.
The Salamis stone represents all the competing ancient Greek measurements: the Doric foot, the Ionic foot, and for the first time, the common foot, virtually the same measurement we use today. Wilson Jones finds evidence of all three measuring systems in the height of the Parthenon.
That distance is at one at the same time 45 Doric feet, that's the ruler on the relief. It's also 48 common feet, which is the foot imprint, and it's 50 Ionic feet, all at the same time. And these are quite exact correspondences.
So the Salamis stone may have provided a simple way for ancient workers from different places to calibrate their rulers and cross-reference different units of measurement. But the Salamis stone may also be a clue to how the ancient Greeks were using the human body to create what we now regard as ideal proportions.
What's extraordinary about this is that at the same time as being a practical device, it's also a kind of model of theory, architectural theory. That a perfect ideal human body designed by nature is a kind of paradigm for how architects should design temples.
Among the first to record that Greek temples were based on the ideal human body was the Roman architect Marcus Vitruvius. He studied the proportions of temples like the Parthenon in the 1st century BCE, 400 years after it was built.
Vitruvius' work gives us the overall frame which is necessary to understand the system of proportions of the Parthenon.
According to Vitruvius, Greek architects believed in an objective basis of beauty that mirrors the proportions of an ideal human body. They observed, among many examples, that the span from fingertip to fingertip is a fixed ratio to total height, and height is a fixed ratio to the distance between the navel and the foot. 2,000 years after the Parthenon, another artist was also searching for an objective basis of beauty.
This is a very famous image. It's drawn by Leonardo da Vinci in the Renaissance, and it's based on Vitruvius' description of the ideal human body, and it encapsulates this idea of its theoretical importance. And what's really interesting for us is that when we superimpose the Salamis relief on this drawing, we see that there's a remarkable correspondence. There are differences, but it's the same principle. You have the same interest in the anthropomorphic principle of giving a kind of sacred, fundamental justification for these measures.
Da Vinci's ideal Renaissance man famously stands in a circle surrounded by a square. Da Vinci named this image Vitruvian Man, after the Roman architect. The ratio of the radius of the circle to a side of the square is 1 to 1.6. That ratio is sometimes attributed to the Greek mathematician Pythagoras, who lived 100 years before the building of the Parthenon. In the Victorian age, it became known as the golden ratio. It was a mathematical formula for beauty. For centuries, many scholars believed the golden ratio gave the Parthenon its tremendous power and perfect proportions. Most notably, the ratio of height to width on its facades is a golden ratio. Today, the golden ratio's use in the Parthenon has been largely discredited. But Manolis Korres and most scholars believe another ratio does in fact appear in much of the building,
The width is, for instance, 30 meters and 80 centimeters. The length is 69 meters and 51 centimeters, the ratio being 4:9.
The 4:9 ratio is also found between the width of the columns and the distance between their centers and the height of the facade to its width.
The Parthenon, like a statue, exemplifies a certain symmetry, a certain harmony of part to part and of part to the whole. There's no question that the harmony of the building, which is clearly one of its most visible characteristics, is dependent upon a certain mathematical system of proportions.
For the Greeks, there was nothing better than a design based on the coming together of measures, of proportions and harmonies and shapes. It's rather like an orchestrated piece of music in which the harmonies of the various instruments are sort of fused together in a wonderful, glorious, orchestrated symphony.
With something like the Salamis stone's use of the human body as units of measure and the idealized human form to define perfect proportions, the Parthenon literally embodies the words of the Greek philosopher Protagoras, who lived in Athens during the construction of the Parthenon. Man is the measure of all things. But proportions and principles do not a perfect Parthenon make.
Next station, Acropolis.
Kathy Porosky has been commuting to work on the Acropolis for 10 years.
Acropolis.
In all her time on the Parthenon restoration team, she's still amazed at one particular achievement of the ancients: their precision.
We have a joint on the step of the Parthenon, which has been so thin, it's like 1/20th of a millimeter, thinner than a hair. Further up, you cannot detect the joint at all. And finally, probably due to an earthquake, a crack starts from one block and continues to the other, and the two behave as one.
This is the level of precision that the restorers need to match today. Their reconstructed column drum number 14192 was taken down because its base didn't fit. To achieve the required precision, they use metal smoothing plates, a technique based on ancient stone plates found on the Acropolis.
It's a very traditional way to level a marble surface. We're putting sand in these holes and they just moving it on the top of the stone. They can make very small differences between the surfaces.
Manolis Koris believes the ancient stone sanding plates could grind to 1/20th of a millimeter. But to stack and precisely align the drums presents an additional challenge. Again, the modern restorers uncover an ancient technique when they separate these two column drums for the first time in 2,500 years.
The ancients aligned the drums very simply, but again ingeniously. They had this block of wood that they cut in half. The lower part was inserted at the center of the lower drum, flush and perfectly fitted, and the upper part is centered in the upper drum coming down. So when the upper drum is placed, it centers onto this pin. The surface was perfectly connected, and it was so airtight that when we opened the drum, we found this, and it's 2,500 years old, intact.
The cedar is so well preserved that restorers could still smell the wood put there by Pericles stonemasons. Today, the modern restorers use the same method, but with titanium. But even though the restoration team has solved many details of the ancients' engineering secrets, they are still at a loss to answer the larger question. How did the Athenians build the Parthenon with all its subtle curves without an architectural plan?
There's a simple problem that to get a plan of this size at a reasonably small dimension that you can grapple with, something like this, which would be around 1 to 50 or so, that would be nowhere near precise enough to deal with all the subtle curvature and the minute adjustments that are also essential for this kind of project.
One of the subtlest of these curves can be found on the Parthenon's columns.
If we pull a string, we can see that from the middle of the column and up, we can see a curve, a very slight curve.
The curve is gentle, starting a little less than halfway up and tapering again near the top. It's an optical refinement called entasis.
Entasis means tension. It gives life to the column visually. It resembles an athlete trying to lift the weight, even the deep breath of the swelling of its chest. It is no longer dead stone. It has life in it. It has pulse.
These deviations from the straight, from the perfectly vertical, from the perfectly horizontal, are analogous to the curvatures and the swellings and the irregularities of the human body. And in that sense, the Parthenon strikes me as being a sculptural as well as an architectural achievement.
The entasis curve on the side of the column is so subtle and so slight, restorers can only draw it by computer. For the ancients to have drawn it at full scale, they would have had to set their compass at an impossible radius of nearly a mile. How they constructed the curved columns was one of the last great riddles left by the ancient Greek temple builders. The answer literally came to light at Didyma, 200 miles from Athens in what is today Turkey. Here, a team of German archaeologists was exploring the ruin of the Temple of Apollo. Built at the time of Alexander the Great, 150 years after the Parthenon, it was the biggest Greek temple ever conceived. 120 columns, each one more than twice the height of the Parthenon's. The German team noted an optical refinement, a curvature on the base of the temple, similar to that of the Parthenon. They suspected there might be more. Traversing the tunnel to the temple's sacred inner sanctum, open to the air, Lothar Hasselberger waited for his eyes to adjust.
Coming out of the darkness of the tunnel into that wide marble hall is a blinding experience. What then, to my surprise, came up were regularly incised horizontal lines, and I found them interesting enough to at least keep them in mind in order to return at a time when everything was under better light conditions. So I was left wondering.
At the mercy of the sun, Hasselberger would have to wait for just the right time of day for the light to reveal more of the mysterious lines.
There's a golden time each day when the sunlight comes just about parallel to the surface.
It was worth the wait.
Coming back, again under better light conditions, it was a kind of revelation because I realized this is a full-sized vertical section of a column, the very one at the front of the temple.
At just the right place in the temple of the sun god Apollo, at just the right time of day, he discovered what might be the answer to the riddle. An almost invisible, scaled-down version of the subtle entasis curve of the columns. This template represents a squashed column. Because it is impossible to draw the curve of the column in full size, The Greeks scaled down the height of the column by a factor of 16. Now, they had a curve that could be drawn with a large compass-like instrument. But the genius behind the template is that the width was not scaled down. So each horizontal line is still the radius of a full-scale column. Now, all a stonemason need do is set his compass to any line of the template to get the diameter of any corresponding point on the column. This simple scale drawing was a key reference for the stonemasons at Didyma as they carved one column drum after another.
Greek stonemasons were so experienced in creating optical refinements like entasis that they may have been given relatively little guidance.
The inscribed template survived at Didyma because the temple was destroyed by an earthquake and remained unfinished. But at the Parthenon, such lines probably disappeared when the walls were polished at the time of completion.
Parthenon was finished, the marble surface is smooth and polished, and with it went what we assume were the construction lines of that temple.
The modern restorers believe the ancient builders must have had some similar kind of template to produce the subtle curvature on not only the columns, but most of the Parthenon's marble blocks.
The key problems are these amazing refinements, the curvature, the inclination, and so on. But once you've got them established, once you know with these blueprints exactly where you're going, then you can proceed down the length of the building and across the front by repetition. So once they get going, they can get going at considerable speed.
With the discovery of the Didyma plans, the restorers have new insight into the last great secret of how the ancients built the Parthenon. But now they face the ultimate test as they place the drum they've so painstakingly reconstructed back on its column. With all its curves and angles, will this new column drum fit? It does.
Yes, we are very happy.
The restorers now need only apply a finish sanding to the most distinctive feature of the columns, the fluting. The crowning achievement will come with the placement of this 12-ton capital on top of the column shaft. For Kores and the modern restorers, this finished marble is more than just another piece of the jigsaw puzzle. They feel they have successfully entered the minds of the ancient builders and discovered how Pericles and his architects were able to design and engineer the ideals of beauty and perfection into this monumental building. Using the same marble and similar techniques and tools, the Acropolis restoration team has reconstructed a part of the Parthenon perhaps as perfectly as the original builders.
In the next 10 years, the work site will be empty and we will be able to admire the perfect proportions of the Parthenon again.
The Parthenon was completed in 432 BCE. As the ultimate expression of Athenian ideals, the temple is adorned with mythological battles of victory. Justice over injustice, civilization defeating barbarity, order prevailing over chaos. And perhaps for the first time on a Greek temple, the Athenians, mere mortals, depict themselves alongside the gods.
And so if the human beings, if the Athenians on the Parthenon frieze are elevated near the rank of gods, the gods are represented in a way that makes them human, and the difference between gods and mortals, between Athenians and the Olympians, is not one so much of kind as of degree. This is an extremely humanistic way of representing themselves.
But the temple and society that built it would not last. Just 1 year later, Pericles goes to the citizens of Athens for funds to equip an army against the threat of Sparta. To pay for it, he suggests they could, if necessary, strip the gold from the great statue of Athena. Soon after, Pericles and a third of the city die from the plague. Athens is crushed by the Spartans, who turn the Parthenon into an army barracks. For the next 2 millennia, the Parthenon would be abused by Romans, barbarians, Christians, Muslims, Turks, with the final insult coming in the 18th and 19th centuries, when Europeans rediscover classical Greece and, out of reverence, plunder much of its remaining sculptures. The most famous of which, the Elgin marbles, are in the British Museum to this day. When the Acropolis restoration project began over 30 years ago, Manolis Korres and his colleagues could have chosen to restore the Parthenon to its original state, adorned with sculpture and friezes painted in vivid colors. Instead, they chose to preserve what has survived these 2,500 years. A majestic ruin, a witness to what we needlessly destroy, and the beauty and perfection that we can create.